Hey guys, Mr. Herc here, and today we're getting into AP Pre-Calc Lesson 3.13. Let's get right into it. So we're going to start with 3-peat F. Pause the video now and try it on your own if you haven't done so already, because I am about to go over the answers. All right, so the first one, we have a rational function, and we want to figure out where is it positive or negative, where is it below 0. So this, we want to get it in factored form first. So this is x minus 3, x plus 1, all over 1 minus x squared is 1 minus x, 1 plus x, which these two are the same. And so we're going to get our zeros at negative 1, comma 3, comma positive 1. So let's plot those on our number line now. All right, now that we have those, we have 1 and negative 1 come from the denominator, so those are automatic open circles. And then to see if 3 will be an open or closed, look at that sign. That has no underline, so we are not going to fill in that circle there. All right, now what we want to do is we want to plug and chug. We want to test in points that fit each criteria or in each range and see which ranges would apply and make this a negative number. So I'm going to plug it into the factored form. Because we're not plugging in 1, we can actually simplify this to x minus 3 over 1 minus x. So plugging this in, negative 2 minus 3 is negative 5 over 1 minus negative 2, which is 3. This is negative, which is good, so we're going to put a check mark there. Having 0 in, we have negative 3 over 1. This is also good, so we will put a check mark there. Here, we have 2. 2 minus 3 is negative 1 over 1 minus 2, negative 1. So this will give us positive 1 as an output, so no. And then 4, plugging that in, 4 minus 3 is 1. 1 minus 4 is negative 3. This should be good too. So what would our solution set be? Well, it's very tricky because we actually do not include negative 1, that exact value, because that will give us a domain error. So we want to have this as our solution set, and then include anytime x is greater than 3. So this right here should be written as 3 comma infinity. So a and c don't have that, so we can eliminate that. And then we want to include this solution set as, or write it as negative infinity comma negative 1 parentheses, and this one as negative 1 comma 1 parentheses. So this, we cannot write this as negative infinity to 1. That is not true because we do not include the value of negative 1 in there. So D is actually going to be our correct answer versus B. B is incorrect. And that's really tricky, but that's why it's so important to understand whether we fill in the circles or we don't fill them in. All right, so let's move on to number 2. What of the following statements is true about this exponential function? So here you just want to see is A positive or negative, and is the B value greater or less than 1? These are the two questions we want to ask ourselves. Here A is positive, so no vertical reflection. That's kind of nice. And then B is less than 1, which means we are going to be having exponential decay. So it should look like this. That we can then automatically say it is not increasing. So it's going to be decreasing, and then this is concave up. So C should be our correct answer for number 2. Number 3, we have a sinusoidal function, A sine B x plus C plus D. We know the maximum value is 14 when x equals 2. And a minimum value is 4 when x equals 8. So if we kind of plug this in here, we get 14 at 2 and at 8. So if we kind of plug that in here, 2 and 8, 2, 14, 8, comma 4 is what we see here. Which of the following could be the values of A and D? So we know our midline is going to be halfway in between our max and our min. So 14 and 4 has a distance of 10 units. We only want half of that. So our midline is going to be at 9, so that's D. So we can eliminate B and D as option choices because we get D as 9. And then here, A is our amplitude, which is going to be half of our total distance from the max to the min. So 5, meaning A is the correct answer for number 3. All right, polar coordinates. So these polar coordinates is a new topic that you have probably never seen before. And so let me begin with an analogy, right? There's many different types of transportation to get from place to place. So far, you've basically only been, in terms of pre-calc, only been driving a car, right? You can only go up and down, left and right on the XY coordinate grid. Now we're going to invent the airplane, essentially. And to get from point A to point B, instead of going over X and up Y, if we want to get to, we'll call this point C, you can just fly directly there instead of making your way across town on the roads. You can just fly straight there, and that's what we're going to be talking about today. And this is going to be polar coordinates in a nutshell. All right, so plotting points and defining functions in space can be done using different ways, each with its own pros and cons. We've seen a rectangular coordinate system before, much like navigating a road, but today we're going to be flying directly to a point, very similar to airplanes. Polar coordinates will be used a lot in trig and working with circles and different things like that. All right, so what is a polar coordinate? Instead of x comma y, that's old news. We don't use that anymore. Just kidding. We will still use that. We now have r and theta. R being our radius of the circle, and theta being our terminal angle, whatever angle this is in standard position. So standard position, yep. And so the good thing or cool thing about polar coordinates is we can write the same point represented in many different ways. And no better way to show that than with an example. So here, example 1, plot and label the following coordinates, polar coordinates, on the polar coordinate grid above. We have 2 comma pi over 3. So you're going to be looking at this pi over 3 line right here and then plotting the point 2. So that is how we plot a polar coordinate. So let's plot the rest of these. This is going to be A. B is 1, a radius of 1, and 3 pi over 2. So that's going to be right here. C is 3, 4 pi over 3. So pi over 3 is 60 degrees. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 right here. And then it should just be a radius of 3. So this is going to be where C is. D is 2 comma negative pi over 6. Negative pi over 6 is, if this is pi over 6, this should be negative pi over 6 going this way. And then it should be a radius of 2. So right here, this is going to be D. All right. Moving on. Now plot these. We have pi over 4 and 2. So that's just right here. That's going to be our A. Let's do B in green now. So we have negative 7 pi over 4. So that's going way over 7 pi over 4, and then we have positive 2. That's actually going to be at the same place. If we do C now, here, we have 2 comma 9 pi over 4. So remember, 9 pi over 4 is 1 full rotation plus pi over 4. That's right here. And so coincidentally enough, it's on the same point. And then D, we have negative 2, 5 pi over 4. And so what you want to do is go 5 pi over 4, which is right here, and then go negative 2, meaning you're going in the opposite direction. Instead of going this way, you're going that way, and this is going to be the same point as well. So this is kind of what I was talking about when I'm saying you can literally write the same point in infinitely many ways because there are infinitely many coterminal angles. All right, so how can we connect rectangular and polar coordinate systems? Remember, rectangular coordinates, we have x and y, and then we are basically forming a triangle and finishing off the other 2 pieces of information with polar, which is our radius or our hypotenuse r, and then theta, our angle that we can use to help us as well. This kind of shows the connections between polar and rectangular coordinates, and so we can convert from one to the other now just using trigonometry that everyone knows and loves. So here, remember, if we wanted to find cosine of this angle, of this triangle right here, cosine is going to be equal to y over r, or sorry, x over r. Geez. Your adjacent cosine will be your adjacent x over your hypotenuse r, and then sine will be your opposite y over your hypotenuse r. So we can solve both of these and get r cosine theta equals your x value and r sine theta equals your y value by multiplying both sides by r. These are two formulas I would probably have memorized to help you convert from polar to rectangular coordinates pretty quickly. And then what happens if you have a polar coordinate? Or what happens when you have, rectangular coordinates and you want to find the polar? Well, you can find your radius pretty quickly using the Pythagorean theorem, and then you can use inverse tangent to help you find your angle measure. So let's take a look here and try some example problems. Convert the following from polar to rectangular. So just remember, x equals r cosine theta, and y equals r sine theta is our two formulas. So here we have our r times cosine theta, or cosine pi, y equals 2 sine pi. This is going to be 2 and 2 times cosine of pi is -1, sine of pi is 0. So our coordinate should be -2, 0 there, which makes sense if we actually plot it, right? You're going over pi degrees and then going over 2. So this point right here should be -2, 0. So if you think about it graphically, you should get the same answer as well. Here we have 4 and 5 pi over 3. So x and y, x equals r cosine 5 pi over 3, and then y equals r sine 5 pi over 3. This is going to be equal to 4, and then this is a 60-degree reference angle, so cosine should be 1/2. Remember, this is also in the fourth quadrant. Geez, so this should be positive 1/2, and then sine should be negative √3 over 2. Simplifying this, you get your coordinate as x to be 2, and your y coordinate to be -2 √3. So our coordinate should be 2, -2 √3. Right? And just to double check, 2, -2 √3, that lies in the fourth quadrant. That would make sense with 5 pi over 3. That also lies in the fourth quadrant. So that's just a quick way to check your work, is just make sure the quadrants align. Here we have -3, 7 pi over 6. So plug that in. All right, so we have -3 for x times cosine 7 pi over 6. That is going to be -√3 over 2 times -3, which is just 3 √3 over 2. And then y is -√3 times -1/2. This is just positive 3 over 2. So our coordinates here should be 3 √3 over 2, 3 over 2 is our xy coordinates for example 4. All right, example 5. Convert the following points from rectangular to polar. So here we have -2 and 2. And so we can use the Pythagorean theorem. 2 squared is 4 plus -2 squared, which is 4, equals r squared. And so this is 8 equals r squared. And so we have √8 equals r, or 2 √2 equals r. So that is going to be our radius, 2 √2. And then how do we find tangent? Well, we have an angle here, and we know tangent of this angle is going to be equal to opposite 2 over adjacent -2, which is just -1. And think about, where is tangent equal to -1? in the second quadrant, that should be positive 3 pi over 4. So that is going to be our answer for A. B, taking a look here, we have 1 comma negative pi over 3. So 1 negative pi over 3. This should be 1 squared plus root 3 squared equals r squared. 1 plus 3 equals r squared. And so we should get 2 as our radius there. So 4 equals r squared. R equals only plus 2, not minus 2. Can't have a negative radius. And then here we want to find tangent. So tangent of theta is equal to opposite, negative root 3 over adjacent. Remember, negative root 3 or even just root 3 is associated with a 60-degree reference angle. So this is going to be 60 degrees, meaning this whole thing is probably going to be 5 pi over 3. So in standard position, so we probably want to write this as 2 comma 5 pi over 3. All right, and then C, this one's pretty easy. You have 0 comma negative 5, so that would be right here. This is probably going to be 270 degrees and then a radius of 5. And so our R is 5 comma, we want to translate 270 degrees into radians, so 3 pi over 2 should be our answer there. And then here we need to rewrite one as root 2 over 2 comma 3 pi over 4. Right, so that should be our answer to example number 5. Example number 6, the location of a point in the plane is given by polar coordinates 7 comma 5 pi over 6. Which of the following is another representation? So what I would recommend is actually just draw out a polar coordinate grid. And so we have 6, so I'm going to split this up into 6. All right, and then let's take a look. 5 pi over 6 is 1, 2, 3, 4, 5, and positive 7. So that is where we're looking at. So this is our star point. We want to see which one aligns with that from our 4 answer choices. So negative 5 pi over 6 is 1, 2, 3, 4, 5. And then that's our negative angle measure. And then negative 7 should be right here. So this is actually where A is going to be. B is negative 7 pi over 6. So this is pi over 6. And then negative 7 should be right here. That is B. That's also wrong. C is negative 7 pi over 6. That would be right here. And positive 7. So that would actually align with the star. So C should be our right answer. Just to check, D, negative pi over 6 is right here, going this way, and then positive 7, this is where D would be. So C is going to be our answer for example 6. I would just sketch a rough graph for these questions though. And then final example, example number 7. The location of a polar coordinate is negative 4 comma negative pi over 2. Which of the following describes the rectangular coordinate? So here we have negative pi over 2. So you're going 90 degrees clockwise. And then negative 4. So instead of it being here, you're going the opposite direction 4. And so this coordinate right here, if this is 4 units away from the origin, should just be 0, right, comma 4. And so D should be our answer for example 7. All right, so if you have any questions, please come see me in office hours, and I will see you guys later. Thanks.